So basic dimensional analysis. And the reason we are really formal kind of in a way with how to approach these easier problems is because when you get into the upper level sciences and math, knowing a process to keep track of your units is really, really helpful. Take it from someone who's just gotten through chemistry courses in college. Knowing how to approach units is extremely beneficial. So let's look at a real simple problem. How can we turn 13.3 yards into inches? We want to convert that, right? So the first thing I want to do is just set up what the first thing that I'm given. So I'm given 13.3 yards. And using dimensional analysis is going to require some ratios and fractions, so I'm just going to turn this into a fraction straight away, just so it kind of makes sense for what we're going to be doing down the road here. So I've got 13.3 yards, and if I want to get all the way to inches, I could go straight to the conversion factor of inches to yards, or I could use feet. I want to show you how to use multiple conversions to get to an endpoint. So let's go to feet. So I know that in my mind's going blank here. In 1 yard, there we go. In 1 yard, there are 3 feet. And so now I've set up my proportions in such a way that my yards are going to cancel. So this unit right here and this unit right here are going to cancel out because one's in the numerator, one's in the denominator. And we talked about that in class. The reason they cancel out is a yard divided by a yard is 1. So it just becomes 1, right? But we're not done yet. We have to get all the way to inches. So the next thing we're going to want to multiply by is a conversion factor for feet to inches. And I know in 1 foot, there are 12 inches. And what's so cool is once you set up this system and you ensure that your units will cancel out, so yards are going to cancel, my feet are going to cancel because there's one in the numerator, one in the denominator, look at what you're left with. Well, in this case, I'm left with inches. So as long as you set up the proportions correctly and all of your units cancel out, you can be guaranteed safe to simply do the calculation now. So you can take a calculator and go, okay, what's 13.3 times 3 times 12, and that without a doubt is going to be the number of inches that reside in 13.3 yards. And obviously I don't have a calculator on here, so if I was to do that, I would need to know now simply what is 13.3 times 3 times 12. And to make this a bit easier, because it doesn't matter the order, I can do this one in my head, so I know that's 36. So that's the only problem I have to do here by hand. So 36 times 13.3. And obviously, you guys aren't allowed calculators on the test. So if you get a hard problem like this, use some of the strategies. You know, it doesn't matter what order you multiply numbers in. So do the easier ones first. So I get 18 there. 18 plus 1, 19. 7, 9, 9, and 3. Have to add. I'm running out of room, so I'm going to write my addition up here. 8, 9, and 9 also make 8, carry the 1. And I get 17, carry the 1, and 4. But I've got a decimal in there. So that's going to be equivalent to 478.8 inches. So 13.3 yards is 478.8 inches, and I set up my proportions in such a way that would allow the units to cancel. Let's do one more example problem. So in this example, we're asked to convert 14 kilograms into pounds. And I went ahead and just wrote the conversion factor we're going to want. So we're going to want to know that 1 kilogram is equal to 2.20462 pounds. And we'll talk about, do we have to use that whole number? Do we have to be that accurate? Well, we'll talk about that. So first, let's set up our proportion. So I know I'm starting with 14 kilograms. So I'm going to begin with that. I'm going to go ahead and write it as a fraction, just because it will look better with all my other fractions. Now I need to multiply that by the conversion. So if 1 kilogram equals 2.20462 pounds, I need to know, should I put the kilograms in the numerator or denominator? That is the question. Well, you want them to cancel out, right? So I've got kilograms up here in the top, so I'm going to put them down here in the denominator. So 1 kilogram is equal to 2.20462, extend the line, pounds. Okay, so the question becomes, do we need to use this whole number? Well, if you have the whole number available in a handy calculator like I do, why not? Let's do the calculation with the full accuracy of our conversion factor and then worry about significant digits at the end. So when I multiply these numbers, but before I do that, actually, notice the kilograms cancel, and we're left with just pounds, right? It's a beautiful thing. So when I plug this into my calculator, yes, I cheated to save time, I got 30.86468 pounds. That was my answer when I did 14 times 2.20462. So how much of these numbers, or how many of these numbers, I should say, should we keep? Well, it has to do with significant digits, right? We have 2 significant digits up here. Our conversion factor is fairly accurate. Goes way out there, right? So how many significant digits should we look at keeping in our answer? Well, depending on the context and depending on what science class you're in, they have rules on significant digits, right? And for this class, what I'm going to ask you is, or not what I'm going to ask you, but what I'm going to tell you is consider the situation. There's no context for this problem. So in the real world, when you're doing conversions, you know exactly what you're getting the measurement for, and you're going to know how accurate you need to be. In this case, let's try to be at least have a calculation or an answer that's at least to the same accuracy as the information we were given. So we have 2 digits here that matter, the tens and the ones. That doesn't mean we only want the tens and the ones in our final answer, but we need at least 2 significant digits, right? So I can look at this, 30. The tens and the ones are there, so those are significant, but I'm going to want to look to that last placed around. So the way I'm going to write my final answer here is 31 pounds. So this is as accurate as the information I was given, but I used 1 digit of accuracy more to help me round, because it's not closer to 30, it's really closer to 31. So this is about 31 pounds. 14 kilograms is about 31 pounds. Okay, I'm going to give you some conversion problems to practice on the next slide, just if you need additional practice, and then the following slide will contain my answers to those problems. Good luck. Here are the 3 practice problems I thought you should do if you're struggling with this. First, I want you to convert 15 centimeters into inches, and then do the same thing but into feet. So you're going to need number 1 to help you do number 2. And then 3 is kind of isolated. Can you convert 101 pounds into kilograms? Hit pause, try these problems, and then review the answers here soon to follow. And here is my work to these problems. And notice that I set them up so the units would cancel. Real quick thing that I would love for you to notice here as well would be down here when I converted 101 pounds into kilograms, I used a different, well, it's not really different, but I used the other conversion. So instead of saying that 1 kilogram equaled, 2 or so pounds, I'm saying that 1 pound is equal to right around half of a kilogram. So it doesn't really matter how you approach the conversion factor. As long as you get the units in the right place in your fractions, it's going to work out in the end, which is what's so nice about dimensional analysis. All right, guys, good luck.